everybody. Thank you so much for having me here. Let me find the clicker so that I know what I'm doing. As Jared mentioned, I do know a lot about how diesel locomotives work because I used to work at a company that predicted failure of heavy machinery. So I used data science and machine learning to predict when diesel locomotives were going to break down. And I came into that role knowing nothing about locomotives of any sort. I had never been in the room with one. But it was one of the most informative and interesting opportunities of my life to get to work on that kind of stuff because it allowed me to see how data science can be applied to different content areas while using sort of similar techniques to bring informative insights into different areas of business. And now I work at a company called Kirmer, which is in the travel industry. Nothing to do with locomotives, but again, I'm using a lot of the things I learned working in data science and heavy machinery to make the travel industry work better and more smoothly. So it's actually an interesting career trajectory and path through data science. And I think that that's one of the things that that has helped me to come to this topic, actually, because when I'm talking about animation and I'm talking about building tools for sort of communicating about your data, there are a lot of different audiences you might be facing, people you might be trying to speak to and really get through to in different areas of business. And you need to design the visualizations and the reporting and the things that you're bringing to that, stakeholder to really hit their, nerve centers, to really put yourself in the shoes of the audience you're trying to speak to. And in my case, I have learned to speak to students in health policy, where I used to teach at DePaul University, people who are mechanics on diesel locomotives, who are very different from students at DePaul, and people now who work in various areas of the hospitality and travel industry. So that's some of the stuff that I want to communicate about this here. And as you can see here, there's a GitHub link. Sorry, the blue is not especially easy to read, but you can also view it on my Twitter account, which was already listed here. So just hit me up on Twitter. I've tweeted the link just minutes ago. So the first thing I want to talk about, because of course, animation, super cool. It is incredibly fun. It looks cool. It makes you look like a rock star when you generate one. Totally. But it is not necessarily always the right thing for every use case. I think we can agree. So I want to talk, before we get into how to do it, whether to do it. We want to have that conversation about what the right strategy is before you're halfway into designing something that may turn out to not be the thing that your audience is really going to find useful. So there are some reasons to generate an animation from a static plot, and there are some reasons not to. If you just think it's cool, do it on your own time, use animation for a Tidy Tuesday project or something like that, but don't put it in front of your boss just because it looks neat, because that is going to end badly for that project, most likely. Showing off, once again, on Twitter, in your own time, that's great. But think when you're generating a plot like this about the audience you're trying to appeal to. And then thirdly, when you look at a data set, if you have a dimension that represents time, whether it's over years or days, if it's time series data of some sort, it can be easy to think, well, time moves in a linear fashion, so my plot should move in a linear fashion. I should use an animation that is sort of time oriented because I have time in my data set. That's not necessarily true. There's no reason that your animation, your visualization should be animated just because time moves forward. However, having time as one of your dimensions is not a reason not to generate your animation if it's appropriate in other ways. Far more meaningful data dimensions is one of my sort of rules of thumb for generating animation. If there's something in this visualization that can't be represented in 3 dimensions or less, then it's going to be busy, it's going to be hard to view on the page, it's going to be too much for the eye to consume, and the audience is going to get overwhelmed or confused. And that might be a time when animating is the perfect way to approach it. Oh no, we went to sleep. Also, if you have a single dimension in your data that has many, many, many levels. So if you're thinking of a data set that, in the case of the example I'm going to show you today, has years represented as one of the dimensions. Time, where it's appropriate to use it, is that I'm looking at over 20 years. So if I want to, as you'll see later, facet this data instead of using animation, I'm gonna have 20 little tiny plots all over my page. That's not gonna work very well. Think about how busy and how crowded and how sort of overwhelming your page will be if you don't use an animation, and balance the audience interpretation. And it's something I tell lots of people: get a naive audience, your, grandma, the guy down the street, whoever, to look at an animation that you're generating or a static plot you're generating and give honest feedback before you're putting this visualization in front of business stakeholders, people that you work with whose opinions are really going to make a big difference. One last detail, and this isn't always a hard and fast rule, but the animation is unlikely to be able to show all the data points on the screen at the same time for the entire data set. It's kind of by the nature of the process, that's one of the reasons you're using an animation, is because you don't have to show everything all at once, one big chunk. But if to understand the data and understand the message you're trying to send with the data, you need to see all the data points at one big time, animation may not be the right choice for you. So there are many great use cases online. The samples and great examples of people using animation to extremely effective ends are endless. Thomas Lynn Peterson is the designer of the GG Animate package, which is what we're going to talk about a lot here. And he's got this plot on the GG Animate webpage as one of the primary examples of how to use it. He is, by my count, representing 6 dimensions in this little plot, because we've got country, we've got continent, we've got GDP, we've got life expectancy, we have the population of the countries, and we have time. So there's a ton going on in this, and it doesn't feel overwhelming. It doesn't feel like this data set is telling you too much, but it's not telling you everything that you could theoretically grasp from this data set. There are some things that are not particularly easy to do, like country against country comparisons. Each dot is a country, they move pretty quickly in this visualization, and they're pretty far apart. So you're really only going to be able to look at the within continent country to country comparisons and not across time necessarily. So think about what you need to say to your audience and what you don't need to say, and design your visualization accordingly. There are multiple other amazing examples. I really encourage you to check these out. There are different use cases for visualization than just time going by. And I really encourage you to look into these, especially if you've got a data set you think maybe animation might be the right choice, but you're really not sure how to sort of frame that. Look at examples of other people's work, steal liberally as we do in the internet age, and it will make your job a lot easier when you're trying to conceptualize this for yourself. So I've already talked a little bit about this, but let's revisit just a moment. Think about design when you're thinking about how to create this visualization. If you're pretty sure that animation is the right choice for you, you think about what you want the audience to take away. Think like an instructor of a class. You are only going to be able to communicate a finite amount of information to an audience in a single visualization. So don't get too carried away. Don't try to sell every insight that could possibly be gleaned from this data set in one plot. And think about each visualization as an opportunity to communicate maybe 1 or 2 insights, and really make sure that it targets that effectively. Movement and speed are not innocuous. They're not just it looks cool when it comes to doing data visualization. If you make a plot move very fast, the audience will subconsciously or consciously think, moving fast must mean something here. It must be a fast-moving trend, or it must be that these things move quickly. And you need to think about whether that's true. And so really take a moment to consider the impact that every choice you make in your visualization process is going to have on the way the audience interprets. Similarly with movement, if one point transitions into another point, the audience is going to think those are the same point, having some sort of transition or some sort of mutation occur. If they're different points and they really don't have a relationship, that transition should not happen between those 2 points. So those are some of the examples of things that you need to be sure to be conscious of and to take into consideration when you're designing. And be conscious every step of the way that you might decide animation was not the right choice for you and have to take a step back, and that's okay. Animation is awesome and very cool, but it's not for everything. So now let's talk hands-on actually how to do this. There are a couple of packages that you need for sure. You need ggplat2, you need gganimate, and you need gifski for this project because I'm generating a GIF, and so you need to have the renderer for that. The other libraries that I've shown here, Transformer Patchwork and ggforce, are very nice to have because they give you a little bit of extra possibility, ways you can arrange plots, additional features that you can use, but they're not mandatory to generate a simple animation plot. First three packages really is all you need. And so we need to understand some concepts that are extensions of the visualization and like grammar of graphics beyond what we think about with static plots. A frame. If anyone here has heard of Walt Disney, we have the image in our head of animators with little paintbrushes painting little animation cells one at a time, and then you do it sort of like a flip book and Donald Duck moves along the page, right? This is the same kind of concept. You're thinking of each frame as a cell of content that are going to be moved together rapidly enough that it looks like an animation. And you are going to generate little frames that will be flowed together. A different issue, a concept that's related but distinct and needs to be thought of that way, is state. For what we're doing, state is the grouping variable that identifies the changes in the data as it moves along. You can have a single state take up more than one frame. Different frames can be the same information. A frame can hold for 1, 2, 3 seconds if you really want to emphasize something, or it can move really fast. It can be a quarter of a second if you just think that frame is just getting us to the next point. But the state is, for example, when we're looking at Thomas Lynn Peterson's plot, the year. The year is the state, and when the state changes, the data moves, and the data moving is really the point that the state is for. Transition is, as you might guess, how it moves from state to state. And we'll talk a little bit about all the different ways that states can move back and forth. And there are many, many choices just in base gganimate that are actually fascinating, some more businessy and some more fun than others. And then entering and exiting. So as I mentioned, a data point that transitions into another data point better be the same data point. It better be the same class or category or dimension or something. But if you have a new class of data or a new level of a dimension coming into your plot, it needs to come in a different way. It needs to be totally unique so that the audience understands this is new. This is not the same data moving through time. And so that's what entries and exits are for. When data comes into the plot for the very first time, it gets an enter, and out goes an exit. So now we're actually going to build a visualization. I promise we will get to some cool graphs. Okay, so I've got an example project here. If you look on the GitHub page, it will give you the data set and give you all of the details. You might need to play with this yourself. But I'm looking at populations who have, particularly refugees, but displaced populations moving in and living in South Africa. Picked it just out random. Data World has great data sets. I highly recommend you check it out if you're looking for data sets to play around with. And this came from them. So I want to look at, where do refugees come from when they're moving to South Africa? Where are those places they're coming from in terms of the local region or someplace else? What are these groups? What are these countries of origin? What are the changes over time in the countries of origin that are most common for refugees in South Africa? And then, is the number stable? Is the overall pattern that the top country is usually the same kind of rough estimate of number? Or is there a sudden boom in refugees coming to South Africa from somewhere? We'll find out using our plot. So I've got a quick little ping in the data set. We've just got, it's already grouped. It's already summarized. It came that way from UNHCR, so that was nice. And if you need to group your data in advance before, you're basically starting with a grouped bar plot. So anything you would do to prepare your data for a grouped bar plot, you will need to do here. I added rank to this and then also filtered just for refugees because that was the population I'm interested in here. So this is the code for the group bar plot that I'm going to start with. We're going to start there and we're going to mutate it into a really cool animation. But this is really all you need to start with. It's very straightforward ggplot, and I don't think it should be a real surprise to anyone in this room. So now here's what it looks like. It's not the most effective plot I've ever seen. It's a lot of years, as I talked about, more than 20 years of data. And there's a lot of countries involved because certain countries are in the top 10 of countries of origin for refugees in certain years and not other years. There's a little bit of mutation in that space. So this is the group bar plot. It's not great. So I want to give it some examples of how you might use faceting to group these countries in a different way, and it's not going to be pretty. It is not good. There's too many countries to show off here, too many years. It's not great. No, let's not with the facets. Okay, facets are great in most cases, and there's lots of uses, but this use case, it calls for an animation. So let's do this. These race plots have been very kind of popular on the internet lately, and I see a lot of people building them in D3 or other frameworks, but you can really build this with ggAnimate in a very simple set of commands. So we had to reformat our plot. We started with this. This is our original, and we're going to go to this. Now, yes, there is a lot changed here. I'll highlight the things. We're basically changing the grouping by to rank. We're changing the theme, styling stuff. We're moving and we're flipping the axis to be sideways. So this is what we get. So what you'll notice is we've got the same data that we had before, but now it's year over year over year flat placed on top of each other, just like animation cells, right? Every year is just stacked right on top of each other, and in this case, completely unreadable. But once we animate it, it will make perfect sense. So how do we visualize it? How do we actually generate an animation out of this? Beep, that's it. One line. Ta-da! And it's moving. Here we go. It's working. It's not perfect. We have things to do yet, and I'll show you how to do those things. But this is all you had to do to make the animation. You start with the ggplot. You make no mutations to the ggplot you started with. Just add the animation stuff to the end, transition states, and off to the races we go. So we can solve some of the problems that were noted on the last slide. Easily, descriptive titles that move with the data and label those bars so we know what they really mean, because they're moving by pretty fast. We need to be able to see what those are without having to find the line down to the x-axis. So here, what we've done here is just taken a couple of small code changes, and as you can see, we've added this thing called closest state. And that is a variable that's unique to the ggAnimate universe that allows us to tell the plot to just take whatever state, which we've talked about, we know what a state is, right? The grouping variable for the whole viz, and render that above. So now we have the year pinging right along as it moves. And we can see all of that. We have our axes labeled beautifully. Things are moving very well. So there are things about how movement happens, though, that we can take into consideration here. So entering and exiting. What if we try grow and shrink when things enter and exit? Why not? Let's give it a shot. So here we go. It looks a little cartoony, right? It's a little woo, brr. It's kind of neat, but I'm not sure that this is a, sort of serving the objective of the audience learning, right? If you're doing this for a Tidy Tuesday project where you're just going to experiment with techniques, give it a try. It's very fun. So we've got, I'm going to actually change that later for the final visualization. But let's talk about the easing, which is the in-plot transitions. We have lots of choices for how the movement between positions on the page can really occur. One thing to note is that you can use functions for this. So the speed can be sort of changing as it moves, cubic, quartic, and so on. And this is what quartic looks like. It's a little fast, so you don't really get to see that it's going, but that's what you can do. You can just do linear. You can just make it move at a constant speed, and that's fine too. But the options are made available to you so that you can really design a visualization that's going to meet the needs of you and your audience. So Bouncy Easing is another one. I call this bouncy. It's called back in and out, but you can see it looks a little like, it's like, and there's another one that's similar to this. It's like springing an elastic band. If this is the sort of thing that you think would make your audience understand the data better, go ahead, use it. It's there, it's available, it could be fun. So then, now that we know how things are going to move, we have in, we have out, we have in between points, we need to think about the timing, because every state can have its own time. You can assign each state an exact amount of time that it's going to stay on screen. And in this case, what I've done is a quarter of a second for every frame except the last one, which gets 20 seconds. Because I want it to move smoothly through life, but then the end I want it to hold on the last one before we swing around to the beginning again. And by saying wrap equals false, I'm making sure that it won't flow from the last year, 2017, back to 1990 whatever, because that's not a linear relationship right there. That the end of time does not flow back to the beginning as Doctor Who might have had, right? So here's what we get now. Slower pace feels smoother. Things are moving in and out with each other. And if we wait long enough, we'll be able to see the end where 2017 stops and moves all the way back to the beginning. But it's because it's all quarter seconds at a time, we have a nice movement there. So 2017, and then boom, right? So quick mention of transition states, because I need to make sure that I don't take too much time with you. States, this transition states is the core element that you need to add to your ggplot in order to make it animated. So states, tell it what state you want to use, what grouping variable needs to go state to state, the length of transitions, so how long should it take to go, quartic or cubic or whatever, flowing back and forth. Give a length to each state as it moves along, as I've talked about. And then that wrap element, making sure that you decide whether transition smoothing should happen between the end and going back to the beginning. So this is our final animation. I have taken added a few little elements to the animate function there so that it can be generated for sending out to a GIF. And then this is how you save it to a GIF. Pretty easy. And that's it. So to conclude, think about whether you need animation, whether it's going to be the right thing for your audience, for communicating the insights you want to communicate. Don't get too overwhelming with your audience. Think about where they're coming from and what knowledge they're bringing to the room. Then, if you're going to make an animation, make it awesome. Make it really, really sharp. Make sure that it has the transitions that are appropriate for the information, that are really going to communicate to the audience exactly what you want to say. And then, get some feedback, test it on naive viewers to make sure that what you think is getting communicated is actually what it's saying. There's some more links, references, things you can find on GitHub from me. But other than that, thank you very much.